Today we're talking about Module 3, Lesson 5 and 6. We're talking about the first consequences of the fundamental theorem of similarity and also some dilations on a coordinate plane. So let's start with our title. And while you're writing this down, pay attention to where the cutout problems are taped into my notebook. I've got one at the top that says, in the diagram we have a center O and a ray OA. And then directly underneath that I have another one that says, in the diagram we have a center O and a ray OA again. So I've got that first cutout with the diagonal line going up and the second with the two parallel lines below as well. So before we start, I want to review that the FTS is the fundamental theorem of similarity. And what that tells us, kind of as simply as we can say it, is that when P and Q are not collinear to O, then PQ is parallel to P prime Q prime, and the distance between P prime Q prime is equal to the scale factor times the distance between P and Q. So because we know that's true, the converse of that statement, or the opposite of that statement, is also true, which is really helpful. So what that tells us is that if we know that P and Q are parallel to P prime Q prime, and we also know that the distance between P prime Q prime is equal to the scale factor times the distance between P and Q, then we can assume that the distance between O and P prime equals R, or my scale factor, times the distance between O and P. And the same thing for O and Q. The distance between O and Q prime is equal to R times the distance between O and Q. So we kind of reversed what we know is the fundamental theorem of similarity, and we're going to use that to solve some problems about how to locate coordinate points. So I have this ray, which is OA, and I want to know what is the actual coordinate point of A prime given a scale factor of 2. So this is really important because that diagonal line, I can't find a precise measurement on it. So what I need to do is use either a horizontal or a vertical line, and then I can kind of take advantage of the fact that I'm going to be creating some parallel lines. So what I'm doing is dropping a point right below that coordinate A to create a coordinate B, which I can see is 5, 0. Now that's really important because now I can use my scale factor of 2 to multiply and get what is B prime, 10, 0. If I draw a vertical line directly above, I will see that coordinate point A prime because, again, B to A must be parallel to B prime A prime, and they are also going to have that relationship of the scale factor. So I'm going to have a relationship of 2 to 1 even in this location. So as you can see, even without a compass, I was able to find the coordinate point of A prime, which is 10, 4. Moving on to this next example that we pasted into our notebook, we can see that the scale factor is 11 over 7, which is a fraction. It's not very easy to use, but we know exactly how to begin based on that previous example. So we drop a point B and we label the coordinate 7, 0. And then we can multiply that by the scale factor of 11 over 7. We can just cross cancel those 7's. And our coordinate point of B prime is 11, 0. So I plot that point, and then I go directly up vertically to that ray OA, and I label A prime. Now, knowing that coordinate point, because of the fact that we have the scale factor, really helps me to place that point without an issue. So again, this is all based on the fundamental theorem of similarity, is that when I'm given a certain point on a ray, I can use either the x or y axis to create that parallel line diagram, which gives me a lot of properties to work with when I'm solving equations. So using that FTS, parallel lines become helpful in finding missing coordinates, and that's without a compass or a straight edge. So moving on, we're looking at Module 3, Lesson 6, which is dilations on a coordinate plane. So if we think about our previous example with a scale factor of 11/7 and an A value, or an A coordinate of 7/11, if I do my multiplication, I can end up with an A prime that is 11, 66 over 7. And if I use my calculator, that's approximately 9.4. So by multiplying A by my scale factor, we found A prime. And that's much easier than trying to use a compass, especially with that Y value of 9.4. That would be really hard to be precise about with a compass and a straight edge. So looking at this last example, it says the coordinates of triangle ABC are shown on the coordinate plane below. So I'm going to label those. The triangle is dilated from the origin by a scale factor of r equals 12, and identify the coordinates of the dilated image. So again, given the scale factor, I can multiply all my original coordinates by 12. So as you can see, I'm writing A, B, and C. And then when I complete that multiplication, I get A prime is the coordinate 24, 24. B prime is the coordinate negative 36, negative 36. And C prime is the coordinate 76, 12.